Deep in the absolute abyss of deep space, more than 1 billion light-years away from Earth, a colossal shadow drifts in total, eternal isolation. It is not a void, nor is it a simple collection of stars. It is an impossible structure so gargantuan that it completely defies the very scale of human imagination. Imagine a galaxy so unimaginably vast that light itself, traveling at nearly 300,000 kilometers per second, takes over 6 million years just to cross from one outer edge of its stellar halo to the other. If this cosmic leviathan were placed where our Milky Way sits right now, it would instantly swallow our entire local group of galaxies whole, consuming Andromeda, the Triangulum Galaxy, and dozens of surrounding dwarf companions like tiny, insignificant specks of dust. This is IC 1101, widely recognized by modern astronomers as the largest single galaxy ever discovered in the observable universe. First glimpsed as a faint smudge of light by astronomer William Herschel in 1790, this celestial monster was long mistaken for a simple nebula. Today, advanced space telescopes reveal it to be an absolute titan. Housing over 100 trillion stars and containing the mass of thousands of Milky Ways combined, this ancient supergiant elliptical galaxy dominates the very center of the Abell 2029 galaxy cluster. Yet, as scientists peer deeper into its glowing heart, an unsettling paradox begins to emerge. Why did this cosmic giant stop growing? How did it swallow hundreds of neighboring systems over billions of years, only to become a silent, stagnant stellar graveyard? And what monstrous engine lurking at its core controls the ultimate destiny of an entire region of space? To uncover the true nature of IC 1101, we must journey back billions of years into the violent early history of our cosmos, where gravity acted not as a gentle architect but as an insatiable predator. To understand the sheer magnitude of IC 1101, one must first dismantle everything we thought we knew about normal galaxies. Our own Milky Way is by no means small, stretching roughly 100,000 light-years across and containing upwards of 200 billion stars. For centuries, humanity believed our home stellar island represented a standard benchmark for cosmic structures across the universe. But IC 1101 completely shatters that comfortable perspective. Located within the dense core of galaxy cluster Abell 2029 in the constellation Serpens, this celestial behemoth is classified as a supergiant elliptical, or CD galaxy. Deep astronomical surveys, including recent ultra-deep high-precision imaging from the Isaac Newton telescope, reveal that its faint outer stellar halo extends across a staggering diameter of nearly 1.7 million light-years, with diffuse outer gas envelopes spanning as far as 6 million light-years across space. Containing more than 100 trillion individual stars, it possesses roughly 200 times the stellar population of our entire galaxy. If you were to stand on a hypothetical terrestrial planet nestled deep inside IC 1101, the night sky would not be a dark canvas dotted with distant, lonely points of light. Instead, it would be an overwhelming, brilliant canopy of ancient crimson stars, illuminating the heavens with a perpetual golden-red glow. Yet this unfathomable beauty conceals a violent origin story. Galaxies of this staggering scale are never born from a single peaceful collapse of primordial gas. They are constructed through eons of relentless, brutal cosmic cannibalism. Over billions of years, the immense gravitational well at the center of cluster Abell 2029 acted as a cosmic funnel, drawing in hundreds of smaller spiral and dwarf galaxies from the surrounding region. Through a process known as dynamical friction, these approaching star systems lost their orbital momentum to surrounding dark matter, spiraling inexorably toward the central abyss. As these unsuspecting star systems plunged into the core, galactic tidal forces tore them apart star by star. IC 1101 devoured its neighbors, absorbing their stellar populations, their interstellar gas clouds, and their vast dark matter halos into its ever-expanding body. Yet, deep within the luminous core of this ancient devourer lies a sleeping terror that defies human comprehension. In recent years, observations from NASA's Chandra X-ray Observatory revealed something far more shocking than mere physical size. The central heart of IC 1101 harbors one of the most massive black holes ever detected in the cosmos, an ultra-massive black hole estimated to weigh between 40 billion and 100 billion times the mass of our Sun. To put this mind-boggling figure into proper perspective, the supermassive black hole at the center of our own Milky Way, Sagittarius, a star, is a mere 4 million solar masses. Even the famous supermassive black hole in galaxy Messier 87, captured by the Event Horizon Telescope, is only 6.5 billion solar masses. The central black hole of IC 1101 is tens of thousands of times larger than Sagittarius A star, with an event horizon so immense that it could swallow our entire solar system dozens of times over without even slowing down. But this monster did not just sit quietly at the center of the galaxy. As Chandra X-ray imagery exposed, the superheated gas surrounding IC 1101 is not calm or stagnant. Instead, astronomers discovered a giant nautilus-like spiral structure of hot gas sloshing back and forth over a distance of 2 million light-years. This cosmic sloshing is the lingering scar of a titanic collision that occurred 4 billion years ago, when another massive galaxy cluster plunged into Abell 2029. The gravitational impact sent massive shockwaves rippling through the intergalactic medium, stirring the superheated plasma like a vast oceanic surge. As the central black hole fed on this swirling reservoir of matter, it unleashed ferocious jets of relativistic energy, blasting intense radiation outward into the galactic medium. These high-energy jets acted as a cosmic blowtorch, heating the surrounding gas to tens of millions of degrees and blowing vast cavities into the cluster environment. And in doing so, the central monster inadvertently sealed its own fate. By violently heating and ejecting the surrounding interstellar gas, the central black hole prevented the cool plasma from ever collapsing to form new stars. In astrophysics, star formation requires gas to cool down so gravity can compress it into stellar embryos. But when relativistic jets inject immense thermal energy into the cluster medium, the gas remains far too hot to collapse. Consequently, IC1101 suffered a catastrophic evolutionary event known to astrophysicists as cosmic quenching. Star formation within this giant came to a sudden permanent halt billions of years ago. Today, IC1101 is essentially a cosmic fossil, populated almost entirely by aging, dying low-mass red dwarf stars and stellar remnants. It is a brilliant, glowing graveyard of staggering proportions, suspended in space without the fresh fuel needed to birth a single new sun. This brings us to a profound scientific paradox that has divided astrophysicists worldwide. Where does a galaxy truly end? Defining the physical boundary of a supergiant galaxy like IC1101 is notoriously difficult. Unlike rocky planets or sharp stellar surfaces, galaxies do not possess clean, solid edges. Their light slowly fades away into the surrounding intergalactic vacuum. Furthermore, recent discoveries of giant radio galaxies such as Alcyonius, which projects colossal plasma lobes spanning over 16 million light-years across space, have sparked intense debate over what truly qualifies as the largest galaxy in the universe. While Alcyonius holds the record for the widest total radio structure due to its magnetized plasma jets, IC1101 remains the undisputed king of actual stellar mass and physical body size. Yet scientists remain haunted by another mystery. If IC1101 has exhausted its fuel and ceased star formation, why do recent deep field images suggest its outer stellar halo is still slowly expanding? The answer lies in the invisible web of dark matter that anchors Abell 2029. The vast gravitational well of the cluster continues to drag in distant dwarf galaxies, slowly shredding them and adding their stellar corpses to IC1101's outer halo. The Titan is dead, yet its shadow continues to grow. This brings our journey full circle back to the dark void of Abell 2029, where we first witnessed that solitary, towering shadow in deep space. What appeared at first glance to be a simple, overgrown galaxy is in truth a cosmic tomb of unprecedented scale, a testament to the ultimate limits of gravitational growth in our universe. IC1101 stands as a living record of galactic evolution pushed to its absolute extreme. It reveals that in the cosmic arena, unchecked growth comes at a fatal cost. By consuming every neighbor within its reach and feeding its central Leviathan, IC1101 inadvertently choked off the very gas needed to sustain its own future. It became so colossal, so dominant, that it silenced its own stellar birth. As we gaze upon this distant Titan through our most advanced telescopes, we are not merely looking across 1 billion light-years of distance. We are looking into the far future of our own galactic neighborhood. Billions of years from now, when the Milky Way collides with Andromeda and eventually merges with the rest of our local group, a similar fate awaits our cosmic home. We too will become a solitary elliptical galaxy, anchored around a central supermassive black hole, floating silently in an expanding universe. IC1101 reminds us of our own fleeting place in this vast, mysterious cosmos. What other secrets lie hidden in the deep dark of the universe, waiting for us to uncover them? Explore the mysteries of space with us. Share your thoughts in the comments below, and subscribe for more Journey into the Unknown. Beyond its immense size and ancient age, IC1101 serves as a fundamental laboratory for understanding the cosmic web itself. Galaxy clusters like Abell 2029 represent the largest gravitationally bound structures in the universe. In these hyperdense environments, galaxies do not evolve in isolation. They interact, collide, and merge in a continuous gravitational dance governed by dark matter. The supergiant CD galaxy at the center is the ultimate beneficiary of this process, accumulating matter from hundreds of merger events over cosmic time. Scientists analyzing the light profile of IC1101 have found that its light distribution does not follow a typical spiral or standard elliptical galaxy curve. Instead, its outer envelope decays very gradually, blending almost seamlessly into the diffuse intracluster light of Abell 2029. This intracluster light consists of billions of stars that were stripped from their parent galaxies during past collisions and now float freely in the cluster potential. In a very real sense, IC 1101 is not just a galaxy but the physical embodiment of the cluster itself. Its outer halo is a cosmic graveyard of devoured worlds, each star tracing a trajectory shaped by the collective gravity of trillions of solar masses of dark matter. When we look at IC 1101, we are witnessing the final stage of galactic cannibalism, a state where a single supergiant structure has consumed virtually everything within its reach. Furthermore, studying the central black hole of IC 1101 provides critical insights into the co-evolution of galaxies and their central supermassive black holes. For decades, astronomers have observed a tight correlation between the mass of a galaxy's central bulge and the mass of its black hole. In IC 1101, this relationship reaches an extreme endpoint. The central black hole, containing up to 100 billion solar masses, accounts for a significant fraction of the galaxy's core mass. The energetic jets generated during its active accretion phases in the distant past were powerful enough to reshape the density and temperature structure of the entire cluster gas core. This self-regulating feedback mechanism, where the black hole heats the gas and shuts off its own fuel supply, is now recognized as a key reason why the most massive galaxies in the universe are red and dead today. Without active black hole feedback, theoretical models predict that supergiant galaxies should continue forming stars at frantic rates, becoming far brighter and bluer than anything observed in reality. IC 1101 proves that black holes are not merely passive sinks of matter, but active sculptors of cosmic architecture. They govern the life cycle of their host galaxies, dictating when star formation begins and when it must permanently end. As observational technology advances with next-generation observatories like the James Webb Space Telescope and the Extremely Large Telescope, astronomers hope to probe even deeper into the faint outer halo of IC 1101. By measuring the velocities and chemical compositions of individual red giant stars in its outskirts, researchers can reconstruct the detailed merger history of this giant, mapping out the specific dwarf galaxies it consumed over the past 10 billion years. Each stellar stream and faint tidal tail in its halo carries the chemical fingerprint of an ancient world that was absorbed long ago. These observations will allow scientists to test dark matter models at unprecedented scales, verifying how dark matter halos grow and merge in the dense cores of galaxy clusters. Ultimately, IC 1101 is more than just a record holder in astronomical catalogs. It is an awe-inspiring monument to the power of gravity, a window into the deep history of cosmic structure formation, and a humbling reminder of the sheer scale and mystery of the universe we inhabit.